2NURFM.com, a broadcast service of the University of Newcastle.
Just to throw you out of whack a little bit, normally around this time on a Monday, we catch up with the University of Newcastle's Head of Mathematics and Physical Sciences, Professor John O'Connor, but he's been busy doing other things, so he joins us today. We've bumped into this time just for today. Welcome along.
Morning, Dave.
We're talking about an interesting thing today. What is this? This is Tertris and how it associates with coffee stains?
We're going to link coffee stains, Tertris and hard coatings.
Very
all
interesting.
in the one. Yes, it's a bit of a challenge today, but I hope people know what I'm talking about with Tertris. And that's that game where on a
Stacking,
computer,
isn't it?
That's
Stacking
right.
like bricks in it.
You got T's coming down and squares and L shapes and straight bits, and the idea is to try and fill it up with no spaces. Now, I'll go back a little bit in terms of the coatings that people put on glasses, the anti-scratch coatings or sometimes anti-reflective coatings, but they also put coatings on special materials to reducing wear in vehicles, in machines, machine tools. You want them to last longer, so you put special coatings on. And the thing they know about these coatings, whether it's the glasses or the tools or whatever, is they work best when there are no gaps. So now we can see the link between Tertris and coatings. The goal is to try and lay down these films in such a way that you get a really dense film. It not only means that it does the job better, but it's much more predictable in terms of behaviour. And of course, that's what you try to do with Tertris. You try to bring these blocks down, line them all up, move them across left or right so that you fill in all the gaps. And of course, you've got the ability there. You have the different shapes. You can rotate them. You can move them backwards and forwards. But it also links to coffee stains. So if you look inside your coffee mug after it's dried, you'll invariably see that the coffee is out around the edge of the ring. It doesn't dry uniformly.
Yeah.
And so you've got this brown stain on the outside. And scientists have been looking at these things. Of course, they get a bit bored after looking at making dense films and so forth, and they get staring at a dried up coffee mug. But it turns out that we can tell a lot about the coffee itself that form these stains from the way it does form, the way that ring forms. And what happens is the reason it forms a ring is that as the droplet starts to evaporate and shrink, it gets locked at some point, usually against a small defect or something in the mug, and so it stops pulling back. The edge of the liquid stays there. It continues to evaporate, and it evaporates quite significantly from the edges, and the fluid keeps flowing towards the edges, which is where it's evaporating from, and it's taking the grains with it. Now, where the whole thing ties in is that you can tell the shape of those grains at a microscopic level by just actually seeing the nature of how those films form. Because if the grains of coffee are perfectly spherical, then they'll form a very dense film. As they come in towards the edge, they'll joggle around a bit and get into the best possible spot. You'll get a very dense film as it comes from the edge inwards. But if they're ellipsoidal or a slightly irregular shape, they don't get the same degree of freedom. And so when they come in, they get latched on very quickly, and they latch on either to the ends or to the immediate sides, and you get the very large gaps. And so in that case, you'd have a much lighter stain. So you can, without actually taking out a microscope and looking at the grains themselves, you can actually predict what the grains will look like just by determining the gradation of colour from the edge of the coffee stain through into the middle.
Okay, then it's interesting how they've found that information out by the other work they've been doing with their films and the focus.
And when you look at the computer simulations for that, they look exactly the same as the computer simulations that people make for predicting how hard films will grow in terms of optical coatings. They use atoms in that case. They bring the atoms in. If the atoms can come in and move around a bit and jostle around, then you'll form very dense films. But if the atoms come in and they very quickly get captured, they don't have any chance to move, then they produce these very porous, very open structures which don't have the same properties. In fact, they're usually things that will more readily peel off. They'll be affected by humidity and so forth. And so at an atomic level, we're seeing the same thing as we're seeing in a coffee mug, which just goes to show it doesn't matter where you go, there's physics around you.
Yeah, there is most definitely. Thank you for today. We'll talk in a couple of weeks' time.
Thanks, Dave.
Joining us from the University of Newcastle, Head of Mathematics and Physical Sciences, Professor John O'Connor. Now 7